as the syllabus stated, just going to pull that over here. So as the syllabus stated, today we're going to be going over data types, variables, and operators in Python. I hope everyone was able to read chapters 2, 9, and 15. There's also a couple other readings that I found in chapter 1 a little after the fact that I think would have been really helpful to today. Those were basically sections 1.1 through 1.4. If you didn't get a chance to read those before the lecture today, if you could, at some point, I think it'll help with some of the understandings that we'll have, or some understanding some of the materials that we'll be going over today. But we'll see. This stuff is really the beginning of it all, so hopefully it won't be too difficult to wrap your head around at first. Cool. So it looks like we've got about half the class now, so it's a great time to get started. I know some people aren't able to join today, so all right. So we're doing data types, variables, and operators in Python. So let me see about presenting this, and I'm going to ask someone to. So now that I've moved this to full screen, can you still see the PowerPoint? Could someone come off mute and let me know if that's the case or if they're seeing something else?
Yeah, we can see.
Okay, perfect. Thank you. Okay, cool. So yeah, today we're going to talk about data types, variables, and operators in Python. Let's get started. So we're going to go through the PowerPoint first, and then I'm going to just kind of demo everything as we go. So the first data type we want to talk about is one of the more basic data types. We've seen this already when we did our Hello World assignment. So strings are the first data type. They're basically arrays of bytes representing Unicode characters. So they're basically text. Unicode characters are a certain type of encoding that computers support. And there are a bunch of different ways to encode letters and numbers in Python or in a computer, but Unicode is probably the most common version out there. So they're essentially arrays of bytes. We'll talk more about arrays when we get to data structures. But for now, just keep in mind that it's a collection of basically characters. So every data type in Python has a built-in function. The built-in function for strings is this stir function with the parentheses after it. So every function is going to have those parentheses after it. Just keep that in mind. They're very important when you're trying to use those functions. And then examples, we have hello world in single quotes. We can use double quotes. If you want to use a multi-line string, you can use triple quotes. This is to facilitate things like having a new line character in your string. And then you can also do triple single quotes. Something to know about the triple quotes is this is also how you can have multi-line comments. So I'll talk a little bit about comments when I do some demos here, but comments are essentially code that's not evaluated by the Python interpreter. So you can add a comment, like if you just want to take notes to yourself, that's a great reason to put in a comment. Oftentimes you want to comment your code pretty thoroughly anyway, just to let people know what it means. One of the things that you'll find once you really get into programming is you spend more time reading code than writing it. So having comments really helps with that reading code aspect, especially when you're new. And it also helps, when you want to take a break, because it's always great when you're stuck on something to take a break for a couple minutes and then come back. If you comment your code well, then you can, come back and jump right back in. So that's about it for strings. They're relatively simple. And like I said, we already did this for the Hello World assignment. You created a string. That string stated hello world, and then you printed that to the console. The next one is numbers. So there are 3 different types of numbers in Python. There's integers, which are basically whole numbers. The built-in function is int, and examples are 1 and negative 1,337. Basically, any whole number is an integer. Just like in math, that's basically the correlation here. Floats, that stands for a floating point decimal number, and it's like it sounds, it's a decimal number. The built-in function there is float, with the parentheses after it. And then examples are 1.25. We can also write them in scientific notation like I have here. So negative 13.37 E2. So that's like, you know, if you write it out in scientific notation, that's like negative 13.37 times 10 to the power of 2. So you can use scientific notation here. And then same with 1 to the E negative 3. So that's like 1 times 10 to the negative third power. So that evaluates out to 0.001 in that case. And then this one evaluates out to negative 1,337. So it's basically the same number up here, but we're representing it in a float format here. Anytime you use scientific notation, that's a float format. And then there are complex numbers. Complex numbers are imaginary numbers. If we're not really going to end up using these very often, but if you're going to get into like complex theoretical math, maybe you're going to want to use complex numbers. The way you signify a complex number is by adding a J after that number. So that implies that it's an imaginary number. The built-in function for complex numbers is complex. And yeah, and then here's some examples here, 5J and negative 2.2J. So that's just signifying it's an imaginary number. If you're familiar with it in math, it's like, you know, the I in math for an imaginary number. So Booleans. Booleans are binary values. They're either true or false. You can think of them as also like 0 or 1. Anything that has a dichotomy and a strict dichotomy is a Boolean. So true or false is the base type there. So the built-in function there is bool. So it's not the whole word Boolean, just bool. And then examples are true, false, and something important to note here is the capitalized true and capitalized false. This is very important when you're writing those into your program. If you do it lowercase, your program is going to think you're trying to create a variable called true or a variable called false. Never do that. It gets really confusing. Just make sure to actually use true or false with the capital here. Notice it's not wrapped in quotes. If we wrap this in quotes, that would be the string true or the string false. So this itself is one of the keywords in Python. We'll talk a little bit about keywords in some time, but just know, don't wrap it in quotes. That's how you get true or false as a Boolean value. We can also get Boolean values from doing comparisons. We're going to talk about operators here in a minute, but we can do 5 is greater than 6. That's a Boolean value there. It evaluates to a Boolean, and that Boolean is false. And then we can evaluate whether or not X is equal to Y with this equals operator. We're going to talk about operators here in a minute. So that depends on what the values of X and Y are. We can assign X and Y values and then compare whether or not they're equal to each other. And that will evaluate to a Boolean, either true or false. So for variables, we've got they're containers for storing data values. You can declare a variable by assigning it a value using the equals operator. 1 equal sign. You'll notice in the last slide I had a doubles equals sign when I was trying to evaluate whether or not two values were equal to each other. So this is the assignment operator here. The double equal sign is whether or not they're actually is whether or not the values are equal. So say we want to store the greeting hello world in a variable called greeting. We would create the variable greeting, no quotes again, and then we store our string value in quotes, and then we have that stored in our greeting variable. And then we can have x equals 5, y equals 12.0. So here we're assigning x the value 5, which is an integer. And then we're assigning y the value 12.0, which is a float. We could cast it to an int because it has the 0.0, but in this case, it's a float. And you can assign things on the same line using the comma like that. But it's easier to read your code if you just do it line by line. I'm just showing you what you theoretically could do. You could also assign multiple values, multiple variables to the same value. If we say had x equals y equals 5, that would assign x and y both the value 5, and then they're equal to each other. They're the same object in memory. We'll talk about that in a little bit. we can assign them a Boolean value. So we have a yes, no here, and we're assigning it equal to this Boolean expression. That's what you get when you're creating an expression and you're assessing whether or not it's true or false. It's Boolean expression. So we have x is less than y. The value, whether or not yes, no is true or false, depends on what this evaluates to. So assuming that we have assigned x5 and y12, and then we do this yes, no evaluation, the value stored in yes, no is the Boolean value true, because 5 is less than 12. And then if we want to assign a Boolean value, we can, do Boolean equals bool. This just creates a raw Boolean. It isn't necessarily going to be true or false, but yeah, you can assign a Boolean that way. And yeah, that's about it for variables. Before I move on to, I believe operators, yeah, operators are next. Any questions on the data types or variables so far? Great. Okay, cool. So on to operators. So we'll start with arithmetic operators. So for arithmetic operators, we have the plus operator. It means addition. You do 1 plus 2, and our environment will evaluate that to 3. We have the subtraction operator, the minus sign or the hyphen, and 1 minus 2 evaluates to -1. We have the multiplication operator, which is the star. So we can, multiply 1 times 2, and then that evaluates to 2. The division operator is the slash. So we can do 1 divided by 2, that evaluates to 0.5, which would be a float. The modulus operator, so that's the percent sign. Modulus, in case you're not familiar from math, modulus is basically divide these things and take the remainder. So if I did 10 divided by 5, that evaluates to 0 because the remainder in that case is 0. But if I did 12 divided by 5, that evaluates to 2 because the remainder there is 2. So the modulus operator is typically useful for determining whether or not something evenly goes into another number or is an even factor of some other number. So, if I want to decide is 5 a factor of 12, I do the modulus, see if it's equal to 0. If that's not equal to 0, I know 5 is not a factor of 12. It isn't, because I'll get 2 in that case. But 5 is a factor of 10, because if I did 10 modulus 5, then I end up with 0. So in this case, if I do 1 modulus 2, it's going to evaluate to 1, because 1 divided by 2 and then take the remainder is 1. So it's like taking division without evaluating it to the decimal places, essentially, and just taking what's left over at that point. Then we have the exponentiation operator. So exponentiation is like, in this, so it's the double star. And in this case, we're doing 1 to the power of 2. 1 to the power of 2 just evaluates to 1, because 1 times 1 is 1. But say you want to know what 2 to the 3rd power is, then you can do 2 star star 3, and that gives you 2 to the 3rd power, which evaluates to 8. So that's exponentiation. Then we have floor division. Floor division is the double slash. So floor division is basically like you want to evaluate it and don't do any decimals, essentially. So if we did 1 floor division 2, we're going to end up with 0, because you take 1 divided by 2, that's 0.5, and then you floor that. So you drop it down to 0.
Sorry, David.
Yeah, go ahead.
Yeah, sorry, David, it's you over here. Can you please start over for modulus? I didn't follow you well. Please, can you explain again?
Sorry, can you repeat that?
Can you please explain again the modulus?
Yeah, the modulus. Yeah. So the modulus operator is like doing floor division, but taking the remainder. So instead of doing floor division and not considering the decimal after that. So say you have 16 modulus 5. 16 modulus 5, you take 16 divided by 5. How many times does 5 evenly go into 16? So it goes into it 3 times, but what's the remainder then? The remainder then is 1. So 16 modulus 5 is 1. So it's basically you do the division and you take the remainder of doing that division. So it's like you evaluate it without doing decimals, and if there's anything left over, if it doesn't evenly fit into that number that you're trying to divide, then you take that remainder there. If it evenly fits, it's going to evaluate to 0. So 15 modulus 5 evaluates to 0 because 5 fits evenly 3 times into 15. Does that help?
Okay, thank you very much. Yes, thank you very much, David.
Yeah, of course. Any other questions on this? Modulus is definitely one of the hardest math operators to wrap your head around at first, but it is extremely useful at times. Awesome. Yeah, and feel free to stop me at any time if you have any questions, just like Hugh did. But thank you for the question, Hugh. Very helpful. All right, so now we have our assignment operators. So as we saw earlier, we can assign. Is there a question?
Yes, sorry to take you back. The last operation, please. I think it's floor division, something like that. Yes, floor division.
Yeah.
I didn't really got it well.
Yeah, so floor division is like, it's almost like the opposite of modulus. So with modulus, you're taking the remainder, but with floor division, you're just seeing how many times does the number evenly fit into the larger number. So if you, say you have these two numbers you want to divide, you have 21 divided floor division 4. So you try to divide 21 by 4. If you divide that normally, you're going to end up with some decimal number. It comes out to 5.25. But in floor division, you don't want to consider the remaining decimal there. So you end up with just 5 when you do 21 floor division 4. So then you just end up with the value 5 at that point. So it's basically, floor division is basically like doing integer division is another way to think of it. You take two integers, 21 and 4, and you want to divide them and you want to end up with an integer at the end, but it'll always round down. So say we had 23 divided floor division 4. So if we divide 23 by 4 using floor division, instead of getting 6, even though 23 divided by 4 comes out to 5.75, we round down. We always round down with floor division, so that comes out to exactly 5 in that case. Does that help? Any other questions? Great. Yeah, and let me know if that wasn't clear. I can try to explain better later on. But after we get through the slide, I will show you examples of all these, and maybe that'll help. Maybe that'll help wrap your head around it a little bit. Thank you for the question. Questions are very helpful. Remember, if you have a question, chances are somebody else does too. Maybe they just don't want to speak up. So please do ask away. All right, assignment operators. So the first one up here, just a classic assignment. So some value equals. So we have x equals 5. It's the same as x equals 5. We're assigning the variable x the value 5. So we're basically storing the value 5 in the variable x. Yeah, that's the simplest assignment operator. But then we can also kind of combine any of our arithmetic operators with our assignment operator so that we can cut down on the amount of code that we have to write. So we can use the plus equals operator. So that basically means take x and do x plus, and then assign x plus 6. So you're adding 6 to the value that already exists in x. So say up here, we have x equal, so we already assigned x the value 5, and now we want to plus equal 6. That's going to make x equal to now 11. So it's the same as doing x equals x plus 6. Since we've already stored 5 in x, then we get, then the resulting value is that x is storing 11. We can do that same thing with minus equals. So say we have x minus equals 2. So again, let's assume we've already assigned x 5. So we have x minus equals 2 that subtracts 2 from the value already existing in 5 and in x and assigns that back to x. So it's the same thing as doing x equals x minus 2. So assuming it's 5, assuming x is currently 5, so we do x minus equals 2. That results in x storing the value 3 at that point, because we've now subtracted 2 from that value and stored it back in the variable x. We can do the same thing with times equals. So it's the same thing as x equals x times 2. So x times equals 2 is the same thing as x equals x times 2. So again, assuming 5, this would evaluate to 10. So we end up with x stored in the variable 10, or we end up with 10 stored in the variable x after we do x times equals 2 when it started out as 5. Again, same thing with division. So x divide equals 2, same thing as x equals x divided by 2. So we can, so again, assuming x is initially 5, we do x divide equals 2. Now x is storing the value 2.5 because we divided it by 2 and then reassign that back to x. So you end up with 2.5 stored in the variable x. We can do the same thing with modulus equals. So x modulus equals 2 is the same thing as x equals x modulus 2. So again, going back to modulus here, it's seeing how many, so you fit the value that you're modulusing by, and you fit it in however many times you can evenly into the number, and then you take the remainder. So in this case, assuming x equals 5 initially, x modulus equals 2 is doing x modulus 2 and then assigning that back to x. So we end up with 1 stored in x, because the remainder after evenly dividing x by 2 is 1. So instead of the 2.5, we end up with 1 in this case. We can do floor division as well here. So x floor division equals 2 is the same thing as x equals x floor divide by 2. And assuming we have 5 in x, we do x floor divide by 2, and we end up with 2. So up here we had 2.5 for x divide equals 2, but in x floor divide equals 2, we end up with just the value 2 because it's basically integer division. We want just the integer remaining. And then finally, we can also do it with exponentiation. So we can do x exponentiate equal 2. So that is taking the initial value of x and exponentiating it by the value on the right side of your equal sign, and then reassigning that back to x. So we have x exponentiate equal 2. So assuming it's 5 as our initial value of x, we do 5 to the second power for exponentiation. And so then we store 25 back in x. Any questions on this slide before I move on? Oftentimes the most common ones you're going to do are plus equals and minus equals. It's just good to know that these other ones exist. And if it's easier for you to wrap your head around to just do the x equals x minus 2 or anything like that, do that. You don't have to do this shorter hand, but it is a shorter hand that's well accepted and well known in the programming community, so most people should understand what's happening there.
David, can one have let's say 2 assignment operators together? For instance, the floor division and the modulus. Will it return anything?
No, so that's a great question. We can't combine them like this, but what you could do in that case is you can combine it on the other side here. So yeah, great question. We can't combine them in the operator right here, but we can combine them after the equal sign. So say you did want to do x floor division 2 and exponentiate by 2. You would then have like x floor division, so floor divide equals 2 to the power of 2 times x plus 2. The problem there, and the reason you can't do it, is because you have to evaluate your order of operations, and you have to be kind of explicit about what you want to do. Because if you're doing floor divide and exponentiation at the same time, which one do you want to come first? Do you want to do exponentiation first, or do you want to do the floor divide first? If we're going by our typical order of operations with PEMDAS, exponentiation would come before division. But it's hard for the computer to recognize that. In that case, if you want to do both at the same time, it's often better to just do x equals, and then you'd have, say, like x to the power of 2 floor divide by 2. Hope that answers your question. Let me know if there are any other questions.
Okay. Sorry, David. This is Isa speaking.
Hey, Isa.
Okay, yes. For the modulus, right? Let's
Yeah.
say x is equal to 5, right?
Mm-hmm.
So you're saying that the module will be 2.5 given 5, right? Is that
So
what you're
if we
saying?
if we do
It would-
5 modulus 2, that evaluates to 1, because how many times does, so 2 fits evenly into 5 twice, so, and that's 4, and then you kind of subtract that even evaluation into it from the 5, and then you have your remainder, which is 1.
1. I don't really understand. I think it's 5 because it's 2.5, right? So it should be 5.
So so you basically want to see how many times that number can evenly fit in. So, you know, if you're doing 5 modulus 2, then you want to see how many times can 2 evenly fit into 5. It can fit into 5 twice, and we can end up with 4. So then we take that 4 away from 5, and we end up with our remainder there of 1, because we can't fit 2 evenly into 1. So you end up with your 1 remainder there. Something to keep in mind with modulus is that it's always going to be less than, or it's always going to be less than the value you're modulusing by. So the only remainder you can get when you do any number modulus 2, the only remainder you could get is 1, otherwise it's going to be 0. But say you want to do some number modulus 5, then you could have any number, it could evaluate to any number 1 through 4 at that point. Because if it fits another even time in there for to get 5, then, you know, there's no remainder at that point. And I know modulus is really confusing. Hopefully it'll make some more sense when I give some examples, but yeah, please do ask away if you have more questions.
Okay, that was great. However, what about the percentage? Is it not valuable in the modulus?
Percents are valuable, but typically you're going to want to store a percent in a decimal number. So, you know, if you want to store 50%, you would store that as 0.5. There's not really a way to store 50% as a raw of 50%. There's not like a data type of a percentage, if that makes sense.
Okay, it's fine.
Yeah, so if you want to store like 50%, you'd want to do 0.5, because that, you know, 50% percentages translate easily into floating point numbers or into decimal numbers. So if you want a percentage, definitely do, you want to just translate that to a decimal number, or make sure that, you know, say you have a variable where you have a percent stored. You want to you want to name that variable appropriately. First off, you want to say like, say it's like the percent return on an investment. You would want to name that variable investment percent return or something like that. So you know that's supposed to be a percent value. So then you could store an integer in there. Say your percent return is 10%. You're making a pretty solid investment in the stock market, and you're getting 10% back. You could store 10 in that variable. You just have to keep in mind that down the line, when you want to, you know, figure out how much am I going to make off of this in a year, because I'm making 10% annually, you would have to then, you don't want to multiply your base and principal investment by 10. You want to multiply it by 0.1, because 0.1 is equal to 10%. So you'd have to, you know, do something like principal investment times your annual percent return variable divided by 100, and then you get your percentage value. And again, I'll show examples of all these. Hopefully that'll be helpful, but any other questions before I move on? And great questions. Love hearing the questions. Keep them coming. If you have the question, I'm sure somebody else does, so don't be shy. All right, not seeing anyone else unmute, so let's move on to the next one. So more assignment operators. We have and equals. This is a bitwise and don't worry too much about these. Bitwise and gets really complicated. It's basically taking like your number, converting it into bits, and we aren't really going to do any of that here. If it's something you want to learn about, highly encourage you to read about it. It's very interesting stuff when you're doing binary, because it's like taking the binary number, like 2 in binary is 1 0, 1 in binary is 0 1, 3 in binary is 1 1. We're not going to get into that in this class. If you want to learn more about it, I'm happy to send you some resources on binary and bitwise operators, but just know that these exist. And if you ever see it, maybe look up what that bitwise operator is. So and equals is like a bitwise and of on x, and so it'll store x back. The value stored back in x will be like x equals x bitwise and 6. If we have time, I'll write out exactly what this looks like and how this would evaluate, but just know it's not terribly important to know right now. You're very rarely going to see these. So this is or equals, bitwise or equals. So x bitwise or 2 is the same thing as x bitwise or 2, and assigning that back to x. Something I forgot to mention here that's very important is the value you're assigning to always goes on the left, and the value that you are assigning that variable always goes on the right. So you want to assign x a value, x goes on the left, and then equals the value on the right. And that assigns the value on the right to your value on the left. It always has to be that way. It can't go backwards. So just keep that in mind. So this is exclusive or. So with
Hello.
Go ahead. Hey.
Sorry. Please, can you go back to the second row?
Are you talking about this rule here or the
yeah,
the
this
rule
row
with...
here.
Okay,
no,
yeah.
This row here.
Yeah, so this one is
Thank
bitwise or. So bitwise or is basically so bitwise or equals. So we have x bitwise or equals 2. So that's x. That's the same thing as x equals x bitwise or 2. So
the first one is and this is or.
Correct. Yeah, the pipe is or, the ampersand is and. So basically the way these evaluate is like you line up the bits in your number, and if they're both 1, then that evaluates to 1. If one of them is 1, that's going to evaluate to 0 because they both have to be 1 for it to evaluate to 1. And if they're both 0, then it evaluates to 0.
Like in gates, like in
Yeah.
logic gates.
Exactly. And then or is the other way around, like if one or both is 1, then it evaluates to 1. If both are 0, then it evaluates to 0. This one here is the exclusive or. So the exclusive or is, so this is exclusive or equals, we have x exclusive or equals 2. It's the same thing as x equals x exclusive or. So exclusive or means that one has to be 1, the other one has to be 0 in order for it to evaluate to 1. If they're both 1, it evaluates to 0. If they're both 0, it evaluates to 0. Again, don't worry too much about these ones on this page. Just know that they're out there is the reason I'm showing this. So this is a right shift equals. So this is like shifting your bits to the right or left, sorry. So this is the left shift. You shift to the left and you pad zeros on the end of the number. So this is the same. So x left shift equals 2 is the same thing as x equals x left shift 2. And then this one is a right shift, and that's just like shifting, again, padding the left with zeros. X left shift equals 2 is the same thing as x equals x left shift 2. Again, these ones are extremely confusing. I never actually used these in my career. So just know they exist in case people ever show them to you. There are certain fields where you'll need to use them, but we're not going to need to use them in this class. It's just you need to know that they exist.
Hello?
Go ahead.
Okay,
Hey.
so there is and, there is or, there's exclusive or. There is no exclusive and.
Correct, because you can't really have an exclusive and because it's either both are 1 or it evaluates to 0. Because there's no way to really conceptualize like both are not and, like because the exclusive OR is basically saying like one of them has to be false and the other one has to be true. Yeah, exactly. Yeah, and another way to think about these, whenever I say 1 or 0, think of it as true or false, because 0 evaluates to false if you cast it to a Boolean. I'll talk about casting here in a minute. 1 evaluates to true, or any positive number evaluates to true. Any number really that's not 0 evaluates to true if you cast it to a Boolean. We'll talk about casting in a minute here, but yeah, you can think of 1s as true, 0s as false for the sake of these bitwise operations.
Okay, thank you.
Of course. Any other questions? All right, not seeing anyone else on mute. And just know that these operators do exist without the and equals. Clearly, they're over here. The reason I didn't include a slide on that is because you're almost never going to use these unless you're getting into, you know, really low-level programming where you want to play around with the bits in your computer. But you know, that's not gonna be the case for this course, and unless you're getting into hardware development, you're not really going to use it all that much. All right, so we have comparison operators now. So the comparison operators, we have the double equal sign. The description there is equals. So we're checking x equals y. So we're checking is x equal to y. Again, you need the double equal sign here for it to be a comparison. Otherwise, it's going to be an assignment. So make sure to have that. Then we have the not equals, so exclamation point equals. So that's evaluating whether or not they're not equal. So x not equal to y. So in this case, say x is 5 and y is 6. This one will evaluate to false, but this will evaluate to true. The x equals evaluates to false when x is 6 and y is 5. But the x not equal to y evaluates to true when x is 5 and y is 6. So if you want to determine whether or not values are not equal, you use the exclamation equals. Otherwise, you use the double equals if you want to make sure that they are equal to each other. And these are all Boolean expressions that you're building out over here. Anytime you're comparing two numbers, you're building out a Boolean expression because it evaluates to a Boolean. Hopefully that's helpful. All right, so then we have the greater than sign. It looks like someone's drawing on the screen. If that's you, could you please not do that? I don't know how to undo it, but they're popping up all over the place here. Let me see. I'm going to stop sharing and reshare just so I can get those marks gone. I don't want them to detract from the lesson. Okay. Hopefully everyone can see my screen again. So then we have the greater than comparison operator. So we're checking if x is greater than y here, and that evaluates, you know, to a Boolean again. The less than, so here we're checking if x is less than y. And then we can also do greater than or equal to. So say in this case, say we have x and y are both the value 5. In these are both going to evaluate to false. For greater than or less than, that evaluates to false because they are the same number. Their x is not greater than y, x is not less than y, x is equal to y. So this would evaluate to true for the double equals operator. But for the greater than operator, if they're the same number, they evaluate to false. But for the greater than or equal to, then in that case, if x is 6 or x is 5 and y is 5, both of those cases, it's going to evaluate to true. Then we have the less than or equal to operator. So again, in this case, if they're equal, it'll evaluate to true. And if x is less than y, then it'll evaluate to true. But if x is greater than y, that's the only case where it'll evaluate to false. Any questions on this slide? All right, great. Okay, then we have our, just make sure, okay, cool. Then we have our logical operators. Our logical operators are keywords. So keep in mind that there are keywords in Python. This means you can't assign a value to that word. So you can't use and or not as your variable name. Just you'll get an alert about it being a keyword if you try to. You'll also, it also shows up in a different color in Python when it's a keyword. It shows up, or in PyCharm, sorry. It'll show up like orange in PyCharm if it's a keyword. But anyway, so the AND operator, it returns true if both statements are true. So say X is 4, X is less than 5, so that evaluates to true. X is less than 10 because it's 4, that evaluates to true. We AND that together, they're both true, so it evaluates to true. But say X was 7, X is less than 5, X is not less than 5, so this evaluates to false. X being 7 is less than 10, so that evaluates to true. Because they aren't both true, this evaluates to false. Then we have OR, returns true if one of the statements is true. So as long as one of these is true, it'll evaluate to true. So say X is 4 again. So in this case, this evaluates to true because we have 4 is less than 5, so that evaluates to true. 4 is not less than 4. Remember, this is not less than or equal to. So this statement here, X less than 4, would evaluate to false. But since one of them is true, this whole Boolean expression here evaluates to true. So you can chain together Boolean expressions basically with the and, or, and not operators. So the not operator is the inverse of the result. It returns true if the result of the original statement would be true. And if it returns true if the result of the initial statement would be false. So this is, so taking the not, if we can make this Boolean expression in here evaluate to false, then the not makes it true. So say we have, say again, we have 7. So we already set up here, if we have 7, this Boolean expression evaluates to false. But then because we're adding the not on it, it evaluates to true. Something important to note is you need parentheses depending on how you're going to evaluate it. So if I just wanted to determine, if I just wanted to do a not X is less than 5, I can do that. But just make sure you put your parentheses in there. In this case, my intention is to do a not on the X is less than 5 and X is less than 10. That's where I want my not. So I put in the parentheses to make sure it evaluates properly. Otherwise, if I didn't include that, it would just be, is not X less than 5. Parentheses are very important when you're working with Boolean expressions, because not basically just flips the value of whatever it's in front of. Great. Any questions on our logical operators?
Yes, I have a question.
Yeah.
On the operator, or, right? I don't think any statement there is false. Let's say we have X is 3. It could be less than 5 and it could also be less than 4.
Yeah,
so how is it?
That would evaluate to true, but a case where we could have false here is if say X were 6. So if X is 6, then X isn't less than 5, so that evaluates to false. X also isn't less than 4 because it's 6, so that also evaluates to false. When you OR together two falses, you end up with false. So both of the components of your Boolean expression have to evaluate to false in order for an OR operation to evaluate to, in order for an OR, an OR operator to evaluate to false. Both components have to be false. I hope that helps clear things up a bit there. It really depends on the value that you're assigning to X.
Okay. I just wanted to be sure that it depends on the value of X. It's fine.
Yep.
Thank you.
It totally depends on the value of X. So if X was 6, then this would evaluate to false. But if X is 4 or less, basically, it evaluates to true. Cool. Thank you for the question. Very helpful. All right, and then now we have our identity operators. So there's the is and is not operator. This was a typo here with the all caps. I'll correct that before I post or share this with everybody. But just make sure these are all lowercase. Capitalization matters. So don't capitalize them in this case. That's a typo on my part. I apologize for that. So is returns true if both objects are the same object. So this gets a little hairy. It's not exactly equals. It's equals when you're working with the base data types that we have so far. But when we get into more complex data types, like you might have read in your reading about sets and dictionaries, if they aren't the exact same, they might hold, it might be a set that holds the same value, the same values. but unless they're actually referencing the same exact object, is will return false in that case. And I'm going to show you what this means. It's much easier to see than it is to explain, but it's whether or not they're the same object in your computer's memory. The idea there is if you modify, so say X is Y and they're both sets. If X is Y and then I modify X, that modification in the back end also applies to Y because they are referencing the same exact object. But if they're not the same object and they happen to hold the same values, when you modify X and X is not Y, so this evaluates to true down here, then in that case, you end up with, you can modify X without invariably modifying Y. So this is something that's extremely important to keep your mind, or to keep in mind when you're doing lists and more complex data structures, because if they are the same underlying object, but you don't want to modify both objects, you're going to have a problem, because if you modify X, it's going to modify Y in the back end, and you're going to wonder why that happened. It's because they're both referencing the same object in memory. So keep that in mind. It's one of those things that you should, that will come up sooner or later in your programming, and it's a valuable lesson once once you learn it. Trust me, it's happened to me a number of times. Again, is and is not will be easier to show, but any questions on the theory behind it? Great. Okay, and then we have our bitwise operators. I already explained about what these are in the previous slide. I guess this is just a little out of order. That's my bad. So we have the ampersand operator. Its name is and. It sets each bit to 1 if both bits are 1. Or is the pipe, and it sets each bit to 1 if at least one of the bits is 1. The caret is an exclusive or XOR, sets each bit to 1 if exactly one of the bits is 1. The tilde is a not, so it flips all the bits. So if the bit was 1, so say we had a bit string of 0, 1, 0, 1, now our bit string when we not it is 1, 0, 1, 0. And then we have the zero fill left shift by pushing zeros in from the right, and let the leftmost bits fall off. So those basically disappear. Signed right shift, it shifts right by pushing copies of the leftmost bit in from the left, and it lets the rightmost bits fall off. So if you have a bit string that's 8 bits long, it'll remain 8 bits long. You'll just lose whatever was on the left or right, depending on whether you're using the signed right or the zero fill left shift. Yeah, don't worry again too much about bitwise operators. Just know they exist, and if you ever encounter them, do some research. That's the easiest way to learn about these ones, because they're very rare, and I don't want to spend too much time on them because there's more important and valuable things to learn at this time in your journey on learning programming. So at the end of this PowerPoint, I put some links to a number of exercises on W3 Schools. W3 Schools is a great website. Highly recommend it. I use it all the time when I forget something. It happens. You forget something small and you can't remember exactly how it works. You can use W3 Schools to help answer your questions. And they also have some useful exercises. So I have links here to their variables, data types, numbers, strings, Booleans, and operators exercises. It's about like 8 questions. You don't have to do it for homework or anything. I have a different assignment for today, but just know that they exist, and that they're there for you to use if you'd like. Okay, so for the last 10 minutes, I just want to demo a few things. Oh, and one other thing that I forgot to mention. So there are operators that work on strings. So here we have the plus operator, and when you're working with 2 numbers, the plus acts as an addition. But if you're working with 2 strings, it works as a concatenation operator. That's going to be important to know for the assignment today. But it's basically concatenation is taking 2 strings and combining them together. That's really all that is there. So we'll let me demo a few things here. All right. I'm just going to go through this basically slide by slide and show you how everything works here. All right, so strings, you've already seen strings before. I'm just going to do them in the Python console here for now. But remember how to create a a file because that's what we're going to do for, that's what we're doing for our assignment. So strings, you know, again, hello world. This is a string. As mentioned, you can do them in double quotes as well. If they evaluate in the back end of the same string, see, like it's still a single quote string, even though I use doubles there. You could use triple or single quotes, triple doubles, basically, so 3 double quotes. Or you could do three single quotes. They all evaluate to the same string. So just keep that in mind. All right. And something to note, I guess it's easier to show that in here. So let me create a new Python file. So with a single quote string, this causes problems. See how this is showing up a different color now because I tried to add a new line. That causes problems for us. If instead I want a multi-line string, I can do this with the triple quotes, and now this isn't giving me any issues. The only reason that's underlined is because it's you know, not a real word. But so now I can have a string that's however many lines I want. So that's the value of the triple quotes. Single quotes, that won't work. So if you do a single quote and then try to do something here, the way you get it to continue to the next line is by doing the this backslash here. But if I try instead to, like, you know, if I tried to take this out and continue my string like with the triple quote, where I don't have another single quote at the end there, we get an error here, underlined in red. If you want multi-line strings, just use triple quotes. It's the moral of the story here. All right, so numbers. Oh, and one thing to keep in mind is the stir and int things. So let's first go over integers. So 1 is an integer, 2 is an integer, 3, negative 137, an integer. It clearly evaluates to an integer. Don't want to spend too much time on that. Those are pretty obvious. But now say we want to cast our an integer into a string. So we can do stir, which is the built-in function for string. We can do stir 1, and now that outputs the string 1. So keep that in mind. It can be important. It'll be important for your assignment. So say we had 2 strings. So I'm going to assign these variables. So h equals hello, and then w equals world. So now we have h. So there's our variable hello, w, our variable world. Now to show the concatenation operator, I can do h plus w. That concatenates them together. And now we have a full string there. So plus is our concatenation operator. Keep that in mind. It's important. It's going to be important for the assignment because you're going to be concatenating strings together. You're also going to need to cast things together. So say we want to say hello world 1, then we can do stir 1, and that'll work as well. So that's how we can add our 1 in there. But if I try to do just 1 here, I get an error. You can't concatenate a string, can only concatenate a stir, not int, because 1 is an int, to a stir. So I can't concatenate a number to a string. So basically I'm trying to use the plus operator for 2 different things here, for plus and concatenation. When you're using it with a string, it's concatenation. When you're using it with a number, it's actually plus. All right, and then for integers, you can do 1.2. It's an integer. Something helpful is you can use type to figure out what the type is. So I did type 1.2, and that tells me it's a float. If I do type 1, it tells me it's an int. But if I do type stir 1, it tells me it's a string, a stir here. So keep that in mind if you're ever wondering what your variable is. So, you know, I have the variables h and w, and this is the value of variables. I can reference these variables that I already assigned a while ago. So I can do a type h, that tells me it's a string. And if I ever had a string, so I have the string 1, I want to cast that to an int, I can do that just like this. But if I try to cast, say, if I try to cast h, which is just, you know, the string hello, to an int, I get a value error, invalid literal for int with base 10 hello. Basically what that's saying is that's not a number. You can't cast it to a number. so don't try. Yeah, and then as mentioned before, we can do -1 3.37 E2. That evaluates to a float. So notice the decimal here, still a float, and it's scientific notation there. Complex numbers, so say I wanted to convert that to a complex number. So if I want a complex 1, I get 1 plus 0j. Again, complex numbers rarely going to be used, just know they exist. Booleans, true or false, and then you can do a type on those. Again, as I mentioned before, you can't just do true. If I do just true lowercase, it's not defined. It thinks I'm referencing a variable, but so it has to be all caps there. Yeah, so then we can also do like type 5 is greater than 6. It evaluates to a Boolean, so the type there is a Boolean, as mentioned here, and then say we want to do h is equal to w, see if that's true. It evaluates to false, so that outputs a Boolean there. Again, if I did type on that, it would be a Boolean. And if you have say you want to cast something like the number 1 to a Boolean to see what it evaluates to as a Boolean, it evaluates to true. But if we do it with 0, as mentioned, that'll evaluate to false. 0 is synonymous with false when you cast it to a Boolean. Cool. So variables, I already showed some assignment of variables, so I'll just kind of skip past this. Typically, you want to give useful names to your variables, though. So maybe I want to store my name in here, so I can. So my name is David Sciacca, and then say I want to make a greeting that just says hello, and then hello, and then my name. So I can add my name there. Now I output the greeting, hello, David Sciacca. So the now stored in greeting is hello and my name, and then I output that for hello, David Sciacca. So just keep in mind how you can do those things, because you can do this assignment here. You can also do a plus equals with that. So say we did h plus equals world. So now h equals hello world itself, because we can concatenate equals world onto that. Just good to know, not necessarily going to need to use it. All right, so modulus. I know there was a number of questions on that, so I'm just going to skip right to that, because there are probably most questions on that. So if I do 5 modulus 2, that evaluates to 1, because if I do 5 divided by 2, I get 2.5. So we don't want a decimal here, but if I did 5 floor division 2, I end up with 2. So it's basically like, is there any remainder there? If there is, then you're going to have some number outputting for the modulus. So say we wanted to do this random number modulus 17. So the remainder there is 16. So that means 17 fits into it evenly up until, so if we did 1, 2, 8, 3, 7, 2, 0 minus that 16 remainder there. Let me put parentheses in here, minus that 16 remainder, and then modulus it by 17. It's going to evaluate to 0, because whatever this evaluated to, this number, happens to be evenly divisible by 17. So that number is evenly divisible by 17 is what the modulus 17 evaluating to 0 means. Basically, 17 evenly fits into there. Say I want to know what 5 to the 5th power is. I can use the exponentiation operator. Yeah, and then let's just do another modulus 1 modulus 2, because 1 is less than 2. 2 can't fit into 1 evenly, so we end up with our 1 remainder. Hopefully that helps clear up a few things on how modulus works. I highly recommend just trying it yourself. That's the best way to learn it, in my opinion. Same with floor division and exponentiation and such. So our assignment operators. So let's actually do this. So x equals 5. We're just going to kind of go down the list here. So now we have x equals 5. Say we want to do x plus equals 6. Now x equals 11 because we added 6 and reassigned it back to x. So we end up with 11 there. Now say we want to do minus equals 2. So we can do an x minus equals 2. So we're taking the current value of x, subtracting 2 and reassigning it back to x. Now x is equal to 9. And now we want to do x times equals 2. You can watch it over here actually change. This is it. The REPL environment in PyCharm shows you what your variables stored are, which is useful. So we can see that x is 18 now because it was 9 previously, and then we times equaled it by 2. Now say we want to divide equal it by 2. We know it's going to be 9 again. Now we get a float though, because whenever you do division, it's going to evaluate to a float unless you do floor division. Floor division will evaluate to an integer. But if you're not using floor division, then it's going to evaluate to a float. Now we can do modulus equals. So x modulus equals 2. So this is going to evaluate to 1 because 2 doesn't fit evenly into 9. There's going to be a remainder. That remainder is 1. So now we have x is 1. And now we can do x floor division equals 2. So since we're doing floor division, if you take 2 or 1 divided by 2, you end up with 0.5, but you floor that, so you end up with 0. So now x is 0. And then if we want to do x exponentiation equals 2, that because it's 0, it evaluates to 0. But let's give it an actual value. So x equals 5, and then now we're going to do the x exponentiate equals 2, and we end up with 25 because 5 to the second power is 2, and we assign that back to x. And sorry, I'm going through this a little fast. It's just because of time. I realize I'm going a bit over, and I know you guys are all busy, so I'm gonna just try to get through this a little fast. But come back to the recording and watch as needed. Not going to go over these assignment operators. You're likely never going to use them. Comparison operators. So we can do x equals 5. It's not because x is 25, but if we do x equals 25, that evaluates to true because x is 25, as we can see over here. But if we want to say x is not equal to 5, that will evaluate to true because x isn't currently equal to 5, it's currently 25. But say x is greater than 5, that evaluates to true. So notice they're all outputting Booleans here. So x is greater than 5 because it's 25 at this point, but x is not less than 5. That evaluates to false because x is 25. And say now we wanted, but if we say we want to see if it's so is x less than 25? That evaluates to false. Yes.
Sorry, David, we can't hear you anymore, or at least I can't hear you from this end. Maybe you mute her.
You can't hear me? Can anyone else hear me? Hello?
I can still hear. I can hear you.
Hello? Hey, can you hear me?
Yes, I can hear you.
Okay, great.
Yes, we can.
Sorry about that. So yeah, x is not less than 25 because x is 25. X is also not greater than 25 because x is 25 because x is equal to 25. But if we do the less than or equal to 25, then that'll work because x, we're asking less than or equal to. So this is like using our or operator implicitly in here. Same with greater than or equal to 25. That evaluates to true because we're basically checking whether or not, so since we're oring together less than or equal to, like oring together greater than or equal to, because the equal to evaluates to true, that also evaluates to true. So logical operators. So say we have true and false. So notice how they're all showing up in orange here. It means they're keyword arguments. You can't use them or keywords. You can't use them as a variable name. So true and false evaluates to false because they both have to be true in order to evaluate to true. But if we did an or for true or false, that evaluates to true. But if we do false or false, that'll evaluate to false. It's the only way you're going to get those two evaluate. And then say, and then also if you have true or true, that's also going to evaluate to true, because as long as one of them is true, an or evaluates to true. But you can say not false. Not false basically does the inverse of false, and that gives you true. Not true does the inverse of true, which gives you false. You could do, so say we had false or not false. Because this not false is going to evaluate to true, this is overall is going to evaluate to true because we're ORing together a false with a true. So we end up with true there. So that's how you can use those logical operators. All right. Identity operators. So say we have x is equal to 5, y is equal to 5. So they're both equal to 5. X is y. It evaluates to true because they're referencing the same data in memory, because they're referencing the same bit string in memory. But don't worry so much about what I'm doing here. This is just for the purpose of demonstration. So say x is equal to list hello. So I'm creating a list here. So x is this list of characters, basically. We'll talk about lists next week. Don't worry so much about it right now. And now if I again do y equals that list hello, they look like they're the same, right? So I can say are they equal? Yes, they're equal. They're the same list. But are they actually the same object in memory? Let's find out. X is y. They aren't. So that means if I append something to x, so say I want to do append world to it. Now x equals y, not the same because they've both changed. But say I did x equals y equals list hello. So now they are the same object. So if I do x is y, it returns true. So if I modify x and I append, and don't worry about these functions again, this is just for the purpose of demonstration. So x append world, notice over here that both x and y now have world in it because they are the same object in memory. Just keep that in mind. It's something that will trip you up at some point, but it's totally fine. It happens to everybody. Just keep in mind that if I do, x is equal to y, if I assign x equal to y, then we're going to get then they're going to be the same object in memory. Otherwise, they won't unless you're working with a base data type. If you're working with a raw data type like an int, a Boolean, or whatever, then they're going to reference the same bit in memory. But it might feel a little high level for now. Once you run into it for the first time, you'll know what I mean. So we're going to skip bitwise operators, and then there are the exercises that you can do for the week. I will share this PowerPoint with everybody. So I know we're about 15 minutes over today. Excuse me. Any last minute questions before I review the assignment for the week? Cool. All right, so let me
Hello. Hello.
Hi.
Hello.
Hi.
Can you hear me?
Yes, I can hear you.
Okay. Actually, I'm still having some difficulties in incorporating my Python with PyCharm, because let's say I open a new project, right?
Mm-hmm.
Going to a new project, the base interpretation, only 3.8 and 3.9 Python appears, and I don't have 3.8 and 3.9 on my laptop. I have, I think it's 3.0, 2012 version. So I don't know why it doesn't appear on the base interpretation.
Well, so when you select one of those interpreters, are you able to still complete the assignment?
The thing is, when I take a 3.9, it opens a web page and stops. So I can't move forward.
Okay. For sure. Email me after class today, and I'll try to help you with that. Maybe we can jump on a call at some point later today and try to work through it together. Just for the sake of time, I'm going to real quick review the assignment for everybody else, and then you and I can sync back up later on to try to figure out what your issue is. Sound good?
Okay, it's fine.
Cool. All right. So for the assignment this week, you're gonna create a basic financial state calculator. I'm going to send this out in the email. So your client wants a program to generate a basic financial report that users can run regularly to understand their current financial state. This program should be able to store the user's name, their checking account balance, their savings account balance, their investment account balance, their total utility bills, their total credit card debt, their total credit card balance due, their total credit card minimum payment due, their annual credit card interest rate, their loan debt, their loan payment due, like the amount of loan payment due, and the annual loan interest rate, as well as the value of all of their other assets. When run, this program should generate a report like the following. So it'll say hello to the user. So the user's name would go here. The total dollar value of assets you own is, and it'll evaluate the total value of assets owned, and the total dollar value of your debt is currently, and it'll evaluate the total value of your current debt. Therefore, your current net worth is, and it prints out your total net worth here. Your total bills due are, and it gives you the value of total bills due. Once you make these payments, you will have this amount of money left in your checking account and this amount of money left in your bank overall. Additionally, your total credit card debt will be down to, and the remaining credit card debt after making your payment, and your loan debt will be, and the amount of your loan debt after paying it down, and interest is applied for the month, including interest applied on the remaining balance after your payment. Therefore, your total debt will be paid down to, and it'll output your total debt after making all your payments, and your net worth will be, and it'll specify your net worth after making your payments. And then if you instead choose not to pay off your full credit card balance due, and it prints out the current balance due, and only pay the minimum payment due, and it outputs the minimum payment due, you will have some amount left in your checking account and some amount left in your overall bank. So that's your checking and savings account added together. However, you will accrue some amount of interest based on the remaining balance after making your minimum payment on the credit card. You'll accrue that much interest. Your total credit card debt will then be some amount of remaining credit card debt. In this case, your total debt would instead be, after making the payment specified in this paragraph, and your net worth will be whatever amount after making the payments specified in this paragraph here. So basically what you're going to need to do is you're going to want to store all of these in variables, and then you're going to use print statements along with like string concatenation to print out all these values in here. And you're also going to use some of your math operators to do some of the math in here for calculating these values. So basically what I want is a program where I can enter in these values into the program, and it's going to give me this financial report by concatenating strings and using the variables accordingly. If there are any questions on that, feel free to email me after class, but since we're already pretty well over our initial hour, I'm going to have to end it there.